Hello everyone, welcome back. Today we are going to see Coulomb's law. Okay, uh, this is the first law in electrostatic chapter. Okay, so what does Coulomb's law say? It says uh, when two charges, say Q1 and Q2, are kept at a distance r. Okay, then you all know that there exists a force between two charges. They may be like or unlike. Okay, between like forces. Between like charges there exists a repulsive force, and between unlike charges there exists a attractive force. Okay, then this force. Okay, let's say this force is acting on this like this. Okay, so this is a positive charge, this is a negative charge. Then this force F is directly proportional to product of charges. Okay, and this force F is inversely proportional to square of distance between the two charges. Okay, let's say this is one equation one, this is two. Okay. So this is a basic Coulomb's law. Okay, for the statement of Coulomb's law, you can say that electrostatic force of attraction between 2 point charges. Let's say this is also important that these two are what, they are point charges. Okay, between 2 point charges is directly proportional to product of charges and inversely proportional to square of distance between them. Okay, now combining these two equations, what you get, will get from 1 and 2, what we get, that force is directly proportional to q1 q2 upon r. Okay, removing this proportionality constant, what we get, F is equals to k q1 q2 upon r, right? This is what, this is Coulomb's law. Okay, now this k, what this is k, this is what, it is a constant that depends on the medium. Okay, constant depends on medium. Okay, on which medium? The medium that exists between these two charges, that is this medium. Okay, this medium. Okay, and this k is also is equals to 1 upon 4 pi epsilon naught. Okay, uh, and value of k is, it is 9 into 10 to the power 9. What will the unit? The unit will be Newton square per Coulomb. Okay, here epsilon naught is what? Epsilon naught is actually permittivity of the air or vacuum, or you can say the free space. Okay, permittivity. Okay, vacuum. Okay, and its value is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Okay, now the value of k is 9 to 10 power. This is in MKSA system. Okay, okay. Now in CGS system, the value will be what? The value will be 1. Okay. So this is a statement of Coulomb's law, and this is the equation. Okay. Now we'll see that if charges are not in air, okay, means medium is not air or vacuum. Okay, means if we change the medium between the two charges, uh, what will the effect on the force? Okay, and one more thing that you need to remember, that this force F, okay, this force F acts along the line of joining the two charges. Okay, F acts along line of joining, line of joining. Okay, this is a very also, this is also a important point. Okay, now when medium is not air or vacuum, okay, then we'll see what how force will change. Okay, let's say uh, the other medium whose permittivity is epsilon. Okay, then uh, then force will be what? It will be 1 upon 4 pi epsilon q1 q2 upon r square. Okay, epsilon is what? It is permittivity of that medium. Okay, then there is a relationship, that is epsilon is equals to one more thing that I would like to tell, that epsilon upon epsilon naught. Okay, this is actually equal to epsilon r. Here epsilon r is actually relative permittivity. Okay, and this is equals to k. Okay, uh, which you can say that dielectric constant of a medium. Okay, dielectric constant. Okay, epsilon by epsilon naught. So from here what you get, epsilon is equals to epsilon naught into epsilon r, or equal to epsilon naught into k. Okay, so what you can write, force F is equals to 1 upon 4 pi epsilon naught into k q1 q2 upon r square. Okay, when medium is changed. Okay, now uh, you you know that when medium is what, it is air or vacuum, then force is what? Say this is F1, this is F2. Okay, 1 upon 4 pi epsilon naught q1 q2. Here we are not changing the magnitude of charges, we are not changing the distance, we are just changing the medium. Okay, on r square. Okay, now just do one thing, uh, divide these two equations. Okay, so f1 upon f2 is equals to what you will get, you will get 1 upon k. This is f1 is equals to f2 upon k, which means if we change a medium, then uh, from air to vacuum, whose sorry, from air to any other medium whose dielectric constant is k. Okay, then force will get, it will get reduced. Okay, or you can say f1 is equals to sorry, f2 is equals to f1 into k. So this is a basically dependence on dielectric constant of the medium. Okay, now quickly we see that dimensional formula of epsilon naught. Okay, dimensional formula for epsilon naught, since you can also derive from the formula as well. It is m minus 1 l minus 3 t power 4, and this is a dimensional formula of epsilon naught, and unit you can see, unit is Coulomb square per Newton meter. These were some basics about the Coulomb's law. Okay, now what we see, we are going to see Coulomb's law in vector form. Okay, now in Coulomb's law in vector form, let's say this is a point A, a charge is kept, this is a point P. Okay, so q1 charge is here and q2 charge is here, and distance between them is, let's say r. and they are at a distance, let's say this is a point O. Okay, they are at a distance r1 and r2. Okay, this is from the origin. Okay, then what you know that f is what? It is 1 by 4 pi epsilon naught q1 q2 upon, this is a distance r. Okay, upon r square. Okay, but in in Coulomb's law, Coulomb's law in vector form, what we represent that this is a charge one. Okay, so it will be experiences the force due to q2. Okay, right. So this force will be in this direction. They are, we are assuming that they are like charges. So this is for this force is what? It is F12. Okay, that is force experienced by one due to two, and this will be what? It will be F21. Then Coulomb, for Coulomb's line vector form, what we represent that F21 is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square unit vector R12. Okay, here unit vector is what? Unit vector is vector R by mod vector. Okay, so in JEE you can see the question based on this. Okay, and one more thing, F21 will be what? Will be negative of F12 since the direction is what? Opposite. Okay, we have to put the vector sign on. Okay, like so this is a Coulomb sign vector, and what will be the R? It will be mod of R2 minus R. Okay, so thank you.